In this video, we are going to study about the extrema on an interval. We will study the AP calculus standards, function 1 and function 3. Okay, so the success criteria is to identify the relative extrema on the graph, find the increasing and decreasing intervals of a function in a closed and open intervals, justify conclusions about the behavior of a function based on the behavior of its derivative. Also, we have to explain the difference between the absolute and the local or the relative minimum and maximum and give mathematical reasons. We have to determine the critical numbers of the functions and specify the extrema in a closed or the open interval shown in the graph. Okay, look at the graphs and understand that first of all identify if it is the open interval or the closed interval. So look at the starting point here and the ending point over here. You can see that the starting point is the point which is excluded. It means the first point is the excluded point, and similarly the ending point is also excluded. So these are known as the open intervals. So whenever in any graph we have the excluded points in the starting and the ending, then they are said to be the open intervals. Now look at here in the graph the beginning and the ending points. You can see that the first and the last points are closed. Okay, so this points, which is the shaded point, is termed as the included point. So you can see that the points at the start and the end and at the end, they both are included. So, and the whole function from, if we say that this is the starting point termed it as A and the ending point termed it as B, so the A and B is continuous everywhere and the starting and the last point are closed, so we can say that they contain the closed intervals. There are two kinds of the extrema. Number one is absolute extrema and number two is relative extrema. Now when we talk about the extrema, of course the two things come in our mind. One is the maximum and one is the minimum. Right now talk about the absolute maximum and absolute minimum. The other name of absolute maximum and absolute minimum is global maximum or global minimum. So now absolute maximum and absolute minimum refer to the highest point of the graph, no matter wherever you can find it, but it has to be included and the interval should be closed. An absolute minimum is the lowest point of the graph, but make sure that the interval which you are referring is the closed, and the lowest point or the least point of the graph is said to be the absolute minimum. So if we look at the graph, if we see that the graph is enclosed in an interval from A to B and the A point is included and the B point is also included and the whole interval which is given over here in the graph is continuous everywhere. Now if we look at the graph, you can say that this point is the lowest point. Now here is a point and here is a point. Now if you compare these 2 points, you can say that this point which is on the 1, it is yani f of 1 equals to -4 or 1 and -4. This is the lowest point of the graph. Now if we see that this is the one of the point which is on the top or which is the highest point, or there is one more point, this one, which is, now compare and tell us that which one is the highest point. So of course you can say that this point is the highest point of the graph. So that's why it is said to be the absolute maximum. So no matter wherever you could find the highest or the lowest points in the graph, they are said to be absolute maximum and absolute minimum. But make sure that you are referring to a closed interval. Now here, let's talk about relative extrema. So relative extrema's other name is local extrema. Now, as we know that local extrema or relative extrema could be a relative maximum or local maximum and relative minimum or local minimum. Now, local minimum or local maximum, they refer to the highest or the lowest points of the turning, only turning. So here you can say over here that this is the turning. And in this turning, this point is the highest point of the graph. Okay, it is the highest point of this turning. So that is said to be relative maximum. Now, where else you can find the turning? Another turning is here. Now, this turning and this point shows the lowest point of this turning. That's why you can say that this is said to be relative minimum. Now, another thing, we are not concerned while talking about the relative extrema, we are not concerned whether the graph is enclosed in an open interval or you are referring to a closed interval. Wherever you could find the turning, that would be your relative minimum or maximum. This is the point which is the lowest point of the graph. So this can also be absolute minimum. So relative minimum or relative maximum can also be absolute maximum and absolute minimum. Let me introduce to you another terminology, that is critical number. Now, critical numbers are the numbers or the points where the derivative of the function is 0 or the derivative of the function is undefined. Actually, the derivative of the function refers to the slope of the tangent line. So, the places where the slope of the tangent line are 0 or the slope of the tangent line are undefined, they are your critical numbers. Now, you know that if the slope of the tangent line is undefined, it means the function is not differentiable at that point. And if the function is not differentiable, of course, it could have a sharp turn. So look at this graph and find out where the derivative is 0, means the slope of the tangent line is 0. So you can see at this turning, if we make a slope, it is equals to 0. Similarly, over here, the slope of the tangent line is 0. At this point, the slope of the tangent line is 0, and over here, the slope of tangent line is 0. Now you can see over here there is a sharp turning. So on the sharp turning, the slope of the tangent line is undefined. The reason is that over here the function is not differentiable. But these points are said to be the critical points. So find out the critical points. So if we have -1, -2, -3, -4, -5. So we can say at x equals to -5, we have the critical number. X equals to -3, we have a critical number. Here it is 0, 1, 2, 3, 4, 5. So at x equals to 0, we have a critical number. X equals to 2, we have a critical number, and similarly x equals to 4, we have a critical number. So you can see in these two graphs, okay, here in the first graph there is a sharp turn, so the derivative does not exist, the function is not differentiable. In the second graph, here the slope of the tangent line is 0, because you can, on making a tangent line, you will get a horizontal slope. So the derivative is 0. So both are the cases where you can find the critical numbers. You can simply say that if the function f has a relative extrema at x equals to c, then c is a critical number. In other words, we can say that relative extrema only occur at the critical numbers. So no matter the turning is sharp or is smooth, you would have a relative extrema, and those points are said to be the critical numbers. Let's try to understand what is the definition of increasing and decreasing intervals of the function. So we are already familiar with the increasing and decreasing terminologies. Where the graph increase, we have the intervals known as the graph is increasing, and whenever we talk about the intervals, it means we have to give the x values. So look at the graph. What is happening over here? So over here, if we see that the graph is decreasing, right? The decreasing over here. So what does it mean? When the graph is decreasing, you can say that the derivative, first derivative of the function is less than 0, which means that the slope where the instantaneous rate of change is less than 0, or the slope of the tangent line is less than 0. Similarly, where the graph is starting increasing over here, so you can say that the first derivative of the function is greater than the 0, and on the constant it means that the derivative of the function is equals to 0. Now look at the graph here over here. What is happening? You can see that in this part, if I say name it as x1, and over here I name it as x2, the value of the x1, the y value of the x1, I am naming it as f of x1, and over here the value of f of x2, I call it as f prime f of x2. So what have you seen? That x1, in this condition, x1 is less than x2, whereas the f of x1, okay, the first y value is also less than the second y value. So in such cases, you can say that the graph is increasing. Now over here, when the graph is decreasing, so over here, let's suppose the first point of the interval, name it as x1, the last point, name it as x2. The y value of the f of x1, this is f of x1, so name the y value as f of x1, and here x2, so name the y value as f of x2. Analyze that what is happening. The x1 is less than x2, whereas f of x1 is bigger than the f of x2. So in such cases, you can say that the graph is decreasing. Okay, so let's see and look at the example. Determine if the graph will consist of both absolute and relative extrema or just relative extrema. Suppose your stance, determine the coordinate points of the extrema of the function. Now, first of all, have a look over here, and what do you find? That this is the open interval. Okay, why? Because the graph over here, it is excluded. So the given interval a, and if you can say that this is 7, okay, so you can say that the interval of the graph is shown as the 0, which is included, whereas the 7 is excluded. So this is the way we have our graph. Now look at, first of all, find out or indicate where is relative extrema. So the relative extrema means the highest points of the turning. So you can say over here, this is your relative maximum. This is the point where you have relative minimum. Similarly, this is the point you have relative minimum. Now, where is the highest point? The highest point, I can say over here that this is the highest point. But this point you don't know whether it is 7 or it is something else, because 7 is not included. So what is this point, the included point? We don't know. Some of the students, they says that it could be 6.9. Some says it is 6.99 and some says 6.9999. So it is just an assumption. So that's why we will not include, and we will say we will not include that point, and we will say there is no absolute maximum. But yes, there could be an absolute minimum, because this graph shows the maximum size. Now this point at x equals to 1, where already we have a relative minimum, we can say that this point also contains the absolute minimum. So how to determine or how to write it? So we can say that here the points, if they ask you for the coordinates, so you can say over here this is relative minimum and absolute minimum. We have the points like 1 and -10. Okay, over here we can say this is 4 and 40. And over here relative minimum, it's 6 and about 10. So these are our points where we have the relative maximum and minimum. Now look at the graph and determine if the graph consists of both absolute and relative extrema. Okay, so now look at this one. First of all, look at the ending points. You can say that this arrow means that the graph is ongoing. It means it's going up and up and up and up. It's never stops. Similarly, the other side is going up and up and up and up. It doesn't stop. Okay, so here you can see a turning. So this turning is said to be the relative minimum. And similarly, in the same graph, you can say that this point is the lowest point. So this could be also named as absolute minimum. So look at the graph and determine where, indicate the relative extrema, absolute extrema, also the increasing, decreasing intervals, and give reasons if there is no absolute extrema. So let's start with the absolute extrema. So you know that for the absolute extrema, we have the absolute maximum and absolute minimum. So absolute maximum and minimum means the highest and the lowest points of the graph. Look at the graph. Now where is the highest point? This is the highest point, but you can see that the interval is open. So it means you can say there is no absolute maximum. Now where is the lowest point of the graph? Here is the lowest point of the graph, but again there is an arrow, which means that the interval is open from okay, and it goes towards the negative infinity, a very smallest number. So it means we don't have any absolute minimum. Now let's try to find out the relative maximum and relative minimum. Now relative maximum and minimum are actually the turning points. So let's try and find out where is the turning point. So here is the turning point. So this is said to be relative maximum. Here is the turning point. So this is also relative maximum. So either write the coordinates depending on the question, or just write the x value. So here x equals to -3. You have the relative minimum maximum, and similarly x equals to 2. You have the relative maximum. Now where is the relative minimum? Over here there is a relative minimum. Okay, because this is the lowest point of the turning, and similarly this is the relative minimum. So here is the relative minimum, and over here is the relative minimum. So you can write the x values only. So x equals to -1 and x equals to 4. Now we have the increasing intervals. and the decreasing intervals. Whenever we talk about the intervals, it means you have to write only the x values. Increasing intervals where the graph is increasing. So you can say from the beginning, the graph is increasing till where you have the relative extrema, yani relative maximum. Now here the arrow, which means that the graph is ongoing from the x side also. So you have minus infinity on that side. So you will start minus infinity till negative 3. You have the increasing interval. After the minus 3, the graph starts decreasing. So here you can see that the graph starts decreasing from negative 3. It's keep on decreasing till negative 1. So you will write negative 3 till negative 1. Now after negative 1, when x equals to negative 1, the graph starts increasing. So the graph again starts increasing till you have the x value equals to 2. And after 2, what happened? That the graph again starts decreasing. So write down from till 4, the graph is decreasing. And after the 4, again the graph started increasing. So it means 4 till infinity again. So this is how we just read the graphs.